In this lesson, let's summarize the information you learned concerning cloud designs. Now, a cloud design refers to the process of planning, creating, and implementing a cloud computing solution for a given organization. It involves selecting and integrating cloud services, such as infrastructure as a service, platform as a service, and software as a service, to meet the organization's specific goals and requirements. Cloud design also includes considerations such as security, data privacy, scalability, and disaster recovery. To ensure you fully understand the basic cloud design concepts, let's quickly review the definitions of some key terms and details that you should know about them for the exam. First, we have cloud deployment models, which are different ways in which cloud services can be deployed. This includes things like public models, private models, hybrid models, and community cloud models. The first deployment model we have is known as a public cloud model. This refers to cloud services that are made available to the general public over the internet. Public cloud deployments are cost-effective and really easy to set up, and they offer scalability and flexibility for your organization. However, organizations have to be aware of the potential security risks associated with sharing resources with other organizations, which is what happens inside of a public cloud model. Therefore, this brings us to our second deployment model, which is known as a private cloud model. Now, a private cloud model refers to a cloud service that is only available to a specific organization or group of users. However, private clouds can be more expensive to set up and maintain, and they're not really as scalable as a public cloud. This is a key distinction between a public and a private cloud model, and it's something you need to make sure that upper management understands when you're presenting your cloud deployment strategies and proposals to them. The third deployment model we have is known as a hybrid cloud model. Now, a hybrid cloud is a deployment model that combines both public and private cloud services into one deployment method. Hybrid clouds are going to offer you the benefits of both a public and private cloud, such as scalability and security. However, they are a lot more complex to set up and manage, and your organization has to be careful to maintain security and compliance across both sides of your cloud infrastructure, including your public and your private sides that are making up this hybrid infrastructure. Our fourth deployment model is known as a community cloud model. Now, a community cloud deployment model is one in which a group of organizations are going to share resources and infrastructure to deliver cloud services. Community clouds can be used for this shared service model, and they are much more cost-effective than using a private cloud. Now, typically, the members of the community cloud need to have similar security requirements to their own internal networks. However, community clouds may not be as secure as a private cloud because everybody is sharing that cloud inside of that community, and they are all using the lowest common denominator when it comes to the level of security that they want to achieve. Now, the second thing we need to talk about is service models, and these are the different ways in which cloud services can be delivered to your customers. This includes things like software as a service, infrastructure as a service, and platform as a service. Now, our first service model is known as SaaS, or Software as a Service. Now, this refers to software applications that are delivered over the internet, and they're typically accessed through a web browser. Some great examples of this is email, customer relationship management software, and human resource management systems. Now, software as a service is really considered a cost-effective way for an organization to access software applications, and it provides them with scalability and flexibility that they wouldn't get with standard technology. Another great benefit of this is that the organization itself is not responsible for managing and updating all those software applications because the cloud provider will do it for you. Now, the second service model we have is known as Infrastructure as a Service, or IaaS. Now, this refers to the delivery of virtualized computing resources over the internet, including servers, storage, and networking. Infrastructure as a Service is a cost-effective way for organizations to access computing resources, and it offers scalability and flexibility, much like a software as a service product does. When you're using infrastructure as a service, though, your organization is responsible for managing and maintaining the operating system and applications that are running on the virtual machines that you placed inside of this infrastructure as a service technology. The third service model we have is known as Platform as a Service, or PaaS. Now, Platform as a Service refers to the delivery of a platform for your customers to develop, run, and manage their own applications on top of. Platform as a Service is considered cost-effective and a way for organizations to develop and deploy applications at scale by using scalability and flexibility that's provided by the Platform as a Service. Now, organizations here are still going to be responsible for managing and maintaining their applications because they're the ones building it, but the underlying software stack and technology that's running those applications is going to be handled by the Platform as a Service cloud provider instead of your own organization. Next, we need to discuss the term scalability. Now, scaling in the cloud is a crucial aspect of any modern business because your organization's ability to handle an increasing number of customers or a growing workload is essential for you to be able to ensure that your business stays relevant and competitive in today's markets. Now, scaling is the process of increasing or decreasing the resources of a cloud system to meet the changing needs of the organization. There are two common ways that scaling is done inside of your cloud designs. These are known as vertical and horizontal scaling. Now, vertical scaling, also known as scaling up or scaling down, involves increasing or decreasing the resources of a given server. This can include adding more memory or processing power to a given server, or removing resources to decrease the server's capacity. Now, horizontal scaling, on the other hand, is known as scaling outward or inward, and it involves adding or removing servers from a system to increase or decrease resources. This can be done by adding or removing virtual machines from a cloud provider, or by adding and removing physical servers from your own data center. Next, we need to cover redundancy. Redundancy is a fundamental aspect of cloud computing, and it refers to the process of creating multiple copies of data or resources to ensure the availability and reliability of those systems. In other words, redundancy is a way of achieving fault tolerance by providing a backup or secondary system in case of failures or errors. This is an important aspect of cloud designs because it helps to ensure the continuity of operations, reduces downtime, and prevents data loss. Next, we have high availability. Now, high availability, also written as HA, is a critical aspect of cloud computing, and it refers to the ability of a system to operate continuously without interruption. High availability is going to refer to our ability of a system to remain operational and accessible to all of our users with minimal downtime, and it's considered a measure of the system's overall reliability. Now, high availability is considered a critical aspect of cloud computing because it ensures that all the systems are remaining up and available and accessible even during periods of high usage or unexpected failures. This high availability is achieved through the use of redundant systems, network connections, and other components to take over operations in the case that there's a failure of one of the other components. Next, we have disaster recovery. Now, disaster recovery, also written as DR, refers to the process of restoring IT systems, applications, and data after a given disruption, such as a natural disaster, a cyber attack, or human error. The primary objective of data recovery is to minimize the downtime and data loss, allowing your organization to resume normal operations as quickly as possible. There are several strategies that organizations can implement in order to achieve disaster recovery inside of cloud computing, including the use of backup and restore processes, replication, and failover. Finally, we have recovery objectives. Now, recovery objectives are an important aspect of cloud computing, and they are closely related to the availability and continuity of services. Recovery objectives refer to the desired state of an organization's systems, applications, and data after a disaster or other disruption. There are three main recovery objectives that you need to be aware of. This includes recovery time objective, or RTO, recovery point objective, or RPO, and maximum tolerable downtime, or MTD. Now, the recovery time objective, or RTO, is the amount of time it takes to recover critical systems and data after a disaster occurs. It sets the target for how quickly the organization needs to resume normal operations, and the RTO should be determined based on the criticality of the systems and the data being protected, as well as the business impact of a prolonged downtime. Second, we have recovery point objective, or RPO. Now, the recovery point objective refers to the maximum amount of data that can be lost during a disaster. This recovery point objective is really the target for how up-to-date our data needs to be once we perform a restore if we had a disaster occur. This recovery point objective should be based on the importance of the data being protected and the impact of the data loss on the organization. The third one we have is known as the maximum tolerable downtime, or MTD. Now, the maximum tolerable downtime is the maximum amount of time that the critical systems and data can be unavailable without causing significant harm to your organization. The maximum tolerable downtime is going to be used to set the target for how quickly the organization needs to resume normal operations after a disaster has occurred. So, for the exam, it's important to remember the different deployment models that you can utilize in your designs, along with your service model selection, and a good understanding of how scaling, redundancy, high availability, disaster recovery, and recovery objectives are going to be utilized inside your cloud designs for your organization.